Testing. Okay, just making sure my audio is working. So, I'm going to do a short little video today on the progress I've made on Guardian. And I feel like it's important we go through this step by step. Um, we're only going to really look at this file because that's what I've been working on. This file is called o2coresecurity.header.h. And it's kind of like the core security for the system. And you'll notice I've got some enumerations. Now, before I continue explaining everything, I'm going to explain what an enumeration is. An enumeration is literally just, as you can see here, a listing of things. And I've got a bunch of them here, right? Got a bunch of them here. This one in particular takes care of access type. So is the access sequential, random, reverse, bidirectional scan, so on and so forth. The names are pretty self-explanatory. I'm not going to go into detail of that. Just know that this allows me to choose between items, if that makes sense. And then failure reason, that's another enumeration for a wholly different thing. There's a bunch of enumerations. What's important to note, though, is the following that I'm going to show you. These right here. So, to anyone that's watching this video, Guardian previously was only secured by this. By these two enumerations. Target tier and permission. What does that mean? What that means is before what I'm going to show you, all a person had to do was put in permission, system, and they were in. That's all the person had to do. Now, we have this authority token. And then picture you're wanting to go to France, or you're wanting to go to Europe, or you're wanting to go out of the country. How do you do that? You have to have a passport to leave the country, correct? Well, guess what? But based on the same idea, I have this auth token. It's AUTH token. Okay. And you'll notice the token has a target tier, a permission, a token secret, and a token ID. It also has a bunch of flags to determine whether the token is system, an admin token, a user token, a guest token, if the token is quarantined, blocked, or revoked, and whether or not the token is valid. And then below that, I have some tracking stats, quarantine count, block count, revoke count. And then I have another Boolean flag to determine whether I should expel the token. And then you'll notice that this is still in the private section. So private means, in C++, private means only the things within this little section can access this stuff, right? So if I'm outside the class, if I'm down here in internal messenger, that's a bad example. Hold on. If I'm down here in the auth token ban list, and if I'm not, which I am, auth token ban list. See, he's a friend. If I'm not a friend of this class, I cannot use any of these functionalities. But because I wanted it to be that way, I set up this little friend class. That's another programming feature. This allows auth token ban list to manipulate the token. Now, besides the token, I've also created internal messenger. Internal messenger is kind of like a way to output to the screen if a person's being bad. And it's basically like emit outbound message, access denied, access denied. And I'll show you that in work in a little bit. The authority manager is not relevant to the newest stuff that I've been doing. Security authority is the only place that can create the tokens. Or this place right here, this auth system token. See? There's also a permission handler. Now, the things that I've recently built are the following. So, previously, in the auth token ban list, let me go find it. I think I still have it here. Oh no, I removed it. I removed it. Oh no, I didn't. It's right here. So these are all going to have to get removed. But what's an auth token access? An auth token access is simply this right here. Wait, right here. And you're like, well, what exactly does that do? Well, it's an unordered map. And in C++, in the language that I'm learning, an unordered map allows you to combine a bunch of things together in a list, and hold them together. So what I've created here is a way to this uint64t, that's the token ID. So if you notice up here in auth token, I've got the token ID, a uint64t, a unique identifier for auditing and revocation tracking. So each token has a separate ID, okay? And what I've done is originally I just typed out this everywhere I wanted to put this. But I've created this token access as an encapsulation method. I hope I'm making sense. This is very deep stuff. So what this does is it takes that token ID and throws it in right here, this uint64t. And then this standard, this STD, that stands for standard. This size T is like a number. It's literally just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. So what this allows me to do is it allows me to store a violating token and the count, or the number of times it's done it. So what I now have is these functions. And you'd be like, well, what do they do? Like this token authorized, what does that do? So what it does is it takes first off, it has two parameters, and a function can either have parameters or not. And in this case, it does. So in this case, we're trying to make sure that the calling token, the calling passport, is either admin or a system token, right? So what we have here is we have, oh, okay, no. Okay, so what we have here is we have two different Boolean values. These Boolean values, they literally will just print out true or false, and it's going to go into the target permission handler, which is this bad boy right here, and it's going to call verify system token, which then it's just going to make sure it's a valid token, it's a system token, the tier is a system tier, the granted levels of permission of system, and that the token secret is the expected system secret. And that goes for every single one to verify. So what it's going to do is that this line here is it's going to call the verify system token with the caller, this parameter here, and then it's going to take the token and it's going to see if it's authorized. And so what we have here is an if-else logic block. And what that basically is saying is if the caller is authorized, then return is token authorized. So that's basically saying if this guy here, right here, caller, if the caller is a system or an admin, and the token is a system and an admin, return true. That's going to return true. Otherwise, it's going to, I created a reason, an unauthorized attempt with given token, and then access manager messenger emit outbound, the token, result the messenger's intent, and then it requires an admin tier, the reason, and then the ID. And then it just simply returns false. And that's just one function. So that's that's just making sure that the token is authorized. Okay? So then the thing is, the token also has a timestamp. So what that means, what this is, this allows me to, using a token ID, declare when when it happened. And that's what this function does, set token timestamp. So in this function, we have 3 parameters instead of 2. We have the caller, a token, and then we throw in a timestamp, which is simply standard chrono system clock time point. And that's literally just allows me to then put in a time. So then in the function itself, we have another const, another boolean called isAuthorized. But this time it's not calling the target permission handler. It's calling token access token authorized. See? Token access token authorized. And if it is authorized, then it's going to go to the item, the token access timestamps, and then using these block here, it's going to then go take the ID from the token, and it's going to add the timestamp to it. So what you would do, how you would call this function is that you would be working through your code, or you'd be wanting to set a token timestamp, right? Well, you would put in the caller, you'd put in the token that you're trying to, set that token to, the token that you're trying to set to the timestamp, and then you would throw in the time, which would probably be right now. That doesn't really help explain that much. Let me find another example. Here we go. Oh no, you know what? I'll take a short break. I think I have an explanation. Okay, a little bit better. Another way to explain it. A better way to explain it, I should say. So, for example, in the increment token access, so I had to have a way to increment this, right? Which is what this function down here does. Increment token access. So what we have is, again, an isAuthorized, and I need to honestly change that to the different logic. However, what you'll notice here is we have ++ token access token ID, which is this right here, which gets the token ID. What this does is it adds a count to it with the token ID. So it takes the token ID from the violating token, and it dumps it into the token access, along with the token ID. But then it takes the token timestamp, so that would be identifying when the token was violating, and it takes that token ID, and then it equals, and then it adds in the get current time. Well, the get current time is this function right here. And it literally just returns the current time. So what it will do is, whenever this function is run, it takes the system time and dumps it in, if that makes sense. And it allows for more granular control for the program and system. So that's a singular instance of an auth token access, if that makes any sense. Well, then I got to thinking, because originally, as you'll notice, after all this crazy logic, you'll notice I had auth token access, quarantine count, block count, revoke count, and I thought, man, you know, the whole point of programming is to make it more diverse and make it more integrated. Then I got a crazy hair up my butt, and that's why Guardian is not finished. And you'll see I'm flying by a lot of this code, and this is all the newest stuff that I've built. All the newest stuff. And it's still kind of a mess. But what I wanted to show you is the following. So, after I created that singular counter, if you will, then I was like, well, what if I wanted a way to do system, admin, user, guests, quarantine, block, or revoke? So what I did then is I created a whole new class that takes this auth token access, the singular item, and does it a bunch of times. Now, this is where the logic gets tricky. And this is where I'm very proud, because this is not AI. None of what I've shown you is artificial intelligently generated. It was all generated by hand, all typed out by myself, with a little bit of help from AI. Will not lie about that, but mostly it was myself. So what we have here is a place now to track system accesses, admin accesses, user accesses, guest access, quarantined access, blocked access, and revoked access. So, well, okay, cool. And there's these flags up here that kind of say control token is system, is admin, is a user, is a guest. False, false, false. Everything's false for now. It only gets updated when it's necessary, if that makes sense. So, here's where the tricky logic comes in. This is my baby right now. So the very first function is called internal access control tier matcher. Tier matcher. Oh my, what are we getting into? What are we getting into? So, it's a lengthy one. So in this function, it goes in and it makes sure it's authorized. And if it's authorized, then it goes into a switch. And a switch is a unique statement. A switch allows me to go between multiple elements instead of doing if, else, if, else, if, else, if, else, if, which is ridiculous. Because it would literally be, hold on, let me type it out. It'd be something like this. And I'm not going to actually like type it out to complete, but it would be like if, some parameters, else if, else if, else if. I mean, I'd have to do this like 9 different times for every single one. So instead I can use a switch. Let's go ahead and get rid of that. Don't need that. I can use a switch. Now notice, token, get token tier. There's a function called get token tier, which allows you to take the tokens tier, which is either system, admin, guest, user, user guest, quarantine, block, or revoke, or unknown. But that one's not really used because, well, if it's unknown, it's definitely not valid. So we have a first case. It's called target tier system. Well, if we hit this block, then it's going to go up here to system accesses, and then it's going to call, hold on, let me, token increment, token access. So it's going to take the token ID from token. Oh, let me go back down. It's going to take the token ID from token, right? Token. And it's going to find out whether it's a system, an admin, a user, a guest, quarantined, blocked, or revoked, right? Or default. But let's go through this line by line. This and I created all of it. This was all me, right? I'm very proud of it. And that's why I keep saying me, because like normally I've been using AI, but no, not this time. I wrote this all myself. I'm very proud of it. Now, what does it do though? So it's basically a way for the system to identify who's doing what, where they need to go, etc., etc. So what this does is, if in fact you are a system tier, well, guess what? System access, access control system access, is getting incremented via this token, system access, right? And each one of these has this same thing. So, case, target tier admin. It had, whoa, bad. That's bad. Of course, it has admin access, not system, but it does the same thing, increment token access. And then the same goes for user, but this one's a little different. This one says, is user true? Is guest false? If, and then it goes on to say, if the control token is quarantined. So if this is true, then we have another user access and a quarantine access, which quarantine access hold on, I need to go back to quarantine. Sorry, I got lost in my own code. So what this, like I said, if the token is quarantined already, and it is a user, basically is what this is saying, then of course we have another user access, but this time we have a quarantine access. And from my understanding, I have to go back. I could have sworn. Oh no, I'm getting confused in my own code. I'm the one that wrote it, and I'm getting lost. This is never good. Okay, no, I want you to pay attention though. What's important here is these three numbers here, right? The maximum counts per tier. So the maximum number of counts of quarantine that a token can have in Guardian is 25. The maximum amount of blocks is 5. If the user or the guest or whoever goes above those thresholds, they go to the next level. So that means if you have a user token in Guardian and you already have 24 quarantines, and let's say we quarantine you the 25th time or the 26th time, you're going to get blocked. Simple as that. You're getting blocked. If the quarantine count is higher than 25, you're getting blocked, as you'll see. So, like I said, oh, yeah, okay. So, here, if the token is already quarantined, we make sure that the token is set to quarantine. And I'm going to have to make sure that this is right, because I don't know if that's a right thing. But anyways, you'll notice here, we have another if, nested if. And this is where this gets crazy, because like, look at this. We have case, which is the whole thing. And then we have a couple things going on here. And then we have an if statement. Like if I collapse that, that's what that becomes. Just to kind of show you the size of this thing. If I collapse just that, this is what happens. And, well, okay, so maximum quarantine count, which is 25. So, of course, there's a function to get the count. And that's what this is, this token access, get token count. That's what that does. It gets the number of quarantine or blocks or revokes you have in that little thing I showed you earlier. In that unordered map. Anyway, so like I said, if you've breached the maximum quarantine count, Of course, since it's a user, we have another user access, but this time it's not a quarantine count access. It's a block access. And you'll notice, is user true? Is quarantine false? Is token blocked? Yes. And then token set token block. Now, naturally, with the quarantines, it's 25. Block is not 25. The block count is only 5. So, if you've been blocked more than 5 times, this is what happens to you next. So, again, maximum is 5. If the amount of tokens is greater than 5, or greater than the maximum blocked counts, of course, we increase user access. And then, of course, we revoke. And then we set is user to true, is quarantine to false, is blocked to false, and is token revoked true. That's the end of user. Guest is pretty much the same way. As you can see here, the logic pretty much stays the same. Go ahead and close that. Now, this is where things get tricky again. Because we're in the quarantine case, I had to do something a little bit different. I've got a couple if, else if. And then, of course, each one has its own separate logic branch. And it just keeps going. Like, I mean, every specific, because I had to do it for every tier. And then, of course, oh, and with this function, it repeats itself because you have an else block. Now, you may be wondering, well, okay, why did you just show me all of that crazy code? Well, that's because, let me go back to it. You'll notice something. But what you'll notice the most is when we get to here. Now, the code becomes so much more simplified because I've got tier matcher and progression logic. Each one basically takes the token down a rabbit hole, if you know what I mean. And I feel like I'm gonna have to like revise this and work through it some more. Like I said, none of this works. That I know of. But I think that's good enough for now. It's late. I don't want to keep anyone. You all have a good day.